I'm Professor Pi. Welcome to my daily mathematical adventures. Hey, don't forget me. I'm Cowboy Rufus. I'm your favorite student. Triangles. Specifically, we're going to talk about the triangle inequality theorem. And then we'll review how to find the area and perimeter of a triangle. I'm sure none of my students have done it, but some students forget what they learned in elementary school when they get in high school geometry. I've combined two lessons here, the triangle inequality theorem, and then we're going to review area and perimeter of a triangle. First, let's review the area. This is G.CO.7 and it's GSRT6. I can use the formula to determine the area of a triangle. I'm hoping you could all do that 6 grades ago. I can use the triangle area formula in reverse to determine the missing sides or the altitude. The ACT loves to do it that way. They will tell you the area of a triangle and give you the base and see if you can figure out the altitude. I can find the perimeter of a triangle easier than you think. All you gotta do is be able to add 3 numbers. I can use the triangle inequality theorem to determine if measured segments can form a triangle. Once again, my video will go here in a minute when we're done with it. I've given you 4 or 5 others. If you don't get anything from my video, go watch the others because you need to learn this. The area of a triangle is 1/2 the base times the height. The area of a rectangle is length times width. We also call that base times height. What's a triangle? It looks a lot like half a rectangle. The height is also called an altitude. It is a line from a vertex of a triangle that goes down perpendicular with the base across from that vertex. So it's not altitude unless you see that little square that tells you it's perpendicular. The height or altitude of a triangle might not be in the triangle. Sometimes it's in the right triangle or on the right triangle. Take a look at my right angle. This is the base. That blue one is the height. It's built into the right. If you get a right triangle, one of those that is not the hypotenuse is the base and one is the height. And does it matter? If I turn this that on its side, I'm gonna call the bottom base and the one going toward the top altitude. The altitude was the blue one, now it's the red one. Now it's still the blue one, even though that's a little off center. So I'm gonna say it's 1/2 the base times the height. In a right triangle, it's not gonna matter to me which one you want to get. The height or altitude of an obtuse triangle can be inside or outside the triangle. Here is an obtuse triangle, and you have to extend the bottom baseline out here because this line that we call the altitude or the height is going to be outside the obtuse triangle. Here I have an obtuse angle, maybe that's 100 degrees up there. And on this one, you're going straight down to the base below. So that one's inside the triangle, this one's outside the triangle. Most of the time when you have an acute triangle, the altitude is going to be inside. And once again, it's not an altitude if you don't see this little perpendicular mark. This is the altitude. I challenge you, I said most of the time, challenge you, go home tomorrow, come back the next day and draw me a picture of an acute triangle with the altitude outside. It can be done. You just don't need that angle. Draw it from this angle or this angle, and let's see what you come up with. Now, the area of a triangle is 1/2 the base times the height. So let's actually do one. Here I have a triangle that is 4 millimeters by 4 millimeters. The area of the triangle is 1/2 the base times the height. I'm gonna always call the bottom one base and the one going up height. If the triangle turns sideways, I'm still gonna call the bottom base and this one the height. So it's 4 times 4 times 1/2. We put an 8 in the box. I know this is probably a level way below you. I'm probably on 5th or 6th grade level on IXL. There it is. Now, 9 yards. The ACT does this all the time. The hypotenuse is 9 yards. I don't need the hypotenuse. But the ACT will give you a drawing with 5 or 6 things that you don't need. They'll give you numbers that you don't need. What do you need here? You need 1/2 the base. 8 times 1/2 is 4, times the height is 24. Now, perimeter of a triangle. Perimeter of a triangle has no formula. Perimeter of a triangle has about 3 sides. You add up about 3 sides, and I'm not going to do a perimeter problem for you, but you can see how it's done. You're going to add side 1, add side 2, add side 3. And sometimes they only give you 2 sides. So you need to know mathematics that you've learned to get a 3rd side. You might need a little trig that you've learned. You might need a little Pythagorean theorem that you've learned. If they give you 2 sides and not the hypotenuse, a squared, b squared, c squared to find the 3rd side. So sometimes the challenge is finding the numbers for the sides, but once you have them, you add up 1, 2, 3 numbers. That gets us to the triangle inequality theorem. That probably should be a capital T because it is a real theorem. And once again, we know that you can not prove postulates, but you can prove theorems. The triangle inequality theorem states that the length of any 2 sides of a triangle must be longer than the 3rd remaining side. That is, 5 plus 5 plus 12 will not make a triangle. And I'm going to prove it in a very simple way. It's not actually a geometric proof, it's a geometric demonstration. I need a volunteer from the class. Now, when I get my classroom volunteer up, I'm going to give them a 5-inch marker in black. I'm going to give them a 5-inch red marker. I'm going to give them one ruler, 12 inches long. I just told you 5 plus 5 will not make a triangle. 5 plus 5 plus 12 cannot make a triangle because 5 and 5 are less in a triangle. All right, let's get my volunteer up here. I love it when Professor Pi is talking to somebody that's at home because there ain't nobody here to volunteer but me. So here's the deal. He gave me this here ruler and he gave me these 2, and all I gotta do is keep the bottom of the marker on the ruler, and he wants me to touch the red to the black, and it don't look like it's gonna make it. Let me think about it. I'll just stare at this for a while. He's sure I can't do it because he said this is 5, and this one's 5, and this one's 12, and that ain't gonna make no triangle. So I'm thinking, if I had one that was 10 and one that was 22, and I had one that was 46, since 10 and 22 ain't 46, yeah, I did the math, but that ain't gonna make no triangle either. Let's see. Let me stare at this a minute. I'm sure I can get a solution. I'm pretty bright when because Professor Pi done learned me all this math. I got a solution. Watch this. Hey, Professor Pi, it makes a triangle now. Look, it makes a triangle now. Wasn't exactly what I had in mind, but he did prove my theorem, because the only way he could make a triangle was to break my ruler. Please don't break anything else, cowboy. Thanks for watching another Professor Pi video. Yeah, y'all come back tomorrow. Cowboy Rufus and Professor Pi will teach you something new.